So unless the newest version of C has changed it, the switch statement, have we talked about switch yet? Switch case. Okay, the switch statement should not be able to work on a string in this language. It can work on a character. That's why we declared choice as a character, not a string. What we are switching on has to be something that can ultimately boil down to an integer. And a character can boil down to an integer, right? It's got the ASCII value. If you type in an A, then underneath it all, that capital A is equal to a 65. And so if you type in an A, then it jumps to the A case and does it. And if you leave the break off, what would happen? It would print out you entered an A, but then it would fall through and also print out you entered a B. And if that break was missing, it would also fall through and print out you entered a C. And if that break was also missing, it would also print out you did not enter an A, B, or C. So breaks are really important. The C# language requires the breaks. It calls it a syntax error if you leave them out. But it requires them anyways, right? Which is stupid because, anyways, yeah. So C# is weird in that respect. But C++ and Java, go ahead and let you leave out the break statements. And sometimes for special cases, it might be a good thing. So, for example, like the telephone keypad, you want to type in an A, you need to press the 2 once. You want to type in a B, you're texting somebody on your old soap-shaped cell phone, you got to press 2 twice. If you want to type in a C, you have to press that 2 button 3 times. And then if you want a D, you had to press the 3 button once. And if you wanted an E, you had to press the 3 button twice. And if you wanted an F, you had to press it 3 times. Right? That's familiar? We've all suffered through sending text messages like that, except for all you youngsters. Well, you could set that up in a couple of different ways. You could do this, switch based on the digit, in case A, C out, a 2, ENDL or whatever, right? And then a break. And if it was a B, I'm going to copy and paste because I could print out 22, right? And then I could break. And if it was a C, yep, about time to copy and paste. If it was a C, I'd print out 222, right? That's one way to do it. And then if it was a D, then I would print out a 3, and so on. That makes sense? That would work? It's not correct syntax. I would need my curly brace here, to get it to totally work. Oh, and by the way, guys, another error that, another thing on the exam, find 3 things wrong with it. A lot of people said that I didn't have the curly braces after the if statement. That's not mandatory if the block is only 1 line of code. If the code looks like this, if condition, do one thing, else do something else, that is valid code. You don't have to have the curly braces. It's when you have more than one thing in the block that you have to use the curly braces. So saying that the thing that was wrong with one of the 3 things that's wrong with it, one of the 3 syntax errors, is that there were curly braces. It's a good idea to put the curly braces. It's wise, but they're not mandatory. I may consider revising that one to put the curly braces in so that people don't settle upon that as an answer. Okay, so anyways, that's one way to do it, but you could also do it like this. Switch based on the digit. If it's a C, write out a 2, but don't break. If it's a B, write out a 2, but don't break. And if it's an A, write out a 2 and don't break. Now that looks wrong. And I said don't break, but actually do break after doing that one. And then for D, E, and F, judicious, F, E, D, printing out 3s, and so on, right? Just like if it was an E, we'd print out 2 3s. And if it was an F, we'd print out 3 3s. Okay, so how does this work? Well, this does work the same way, right? If it's a C, it's going to print out a 2, and then it's going to fall through and print out a second 2, and then it's going to fall through and print out a third 2, and then it's going to break, so it'll print 2, 2, 2. But if it was a B, it's going to jump to here, print out the 2, fall through to that one, print out a second 2, and then break. If it's an A, it jumps here, prints out only 1, 2, and it breaks. And then F, E, and D follow the same pattern. There's really not very many times when people use fall through. There's really nothing magically better about this code than this code. This code's a lot clearer. And if I have a choice between writing clearer code and more obscure code, I'm going to go for clearer code. So I can't think of a good reason to implement it like this, but it would work. So are we clear on what the break statement does? The break statement causes it to jump to the first statement after the enclosing semicolon, closing brace. So as soon as it hit this break here, it would jump down and print done. So in this case, if we entered the code with a B, if digit is equal to B, what would it print out? All right, I just talked through it, so somebody tell me, if digit was a B, what's it going to do? It's going to print out that 2, and is it going to break at that point?
No.
So it's going to fall through and print out another 2, and then it's going to break. So it would print out 2, 2, and then since I didn't have E and DLs, it would print out done.
How would it go to the next 2? Because if the digit is B, it should just print out the 2. And
It should print that one out, but there's no break telling it that it's the end of the switch. And that's called fall through.
Oh, okay, I see.
It falls through into the next case. It looks like it shouldn't, right? And that's a common programming error, is you forget to put your break statements. And when I'm typing code up here, giving y'all examples, it's plausible that I'm going to forget to put the break, and then I'll say, oh man, and I'll make us go back up and do it. So the switch statement, that expression inside the parentheses there, has to be something that will evaluate to an integer. So it could be a char, because characters are integers underneath it all. It could be an int, it could be a short, it could be a byte, anything that's compatible with the integer type. And then all of these things have to be constants. So when I did this, or if I did this, switch based on x, and then I had like case 2 and it was supposed to do something, blah, 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 and then break. And then I had a case 3, blah, 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 do something and then break. That's all great. But this would not work. I cannot say, you know, int val1 is equal to 2. Int val, no, that's confusing. Val2 is equal to 2, val3 is equal to 3, and then write a switch statement like this. Switch based on x, and then our cases, if it matches val2, do something and then break. And if it matches val3, this is illegal. This is not going to work. We can make it work by sticking the word const in front of these things. That would make it work, but otherwise it wouldn't. Because at compile time, the compiler is kind of generating a map of what's going to happen, and it doesn't know at compile time what val2 and val3 are going to be, because what if they changed, right? Just because we declared val2 as a 2, then later on we may have said, you know, val2 is equal to 10 minus val2, right? You know, it could have changed. And so these things have to be constant values. They either have to be literals, like we've seen, the 2s and 3s or things with quotes around them, or they better be variables that have been declared as constants. The default is optional, but it's a good idea. you want to tell yourself if none of the possible answers was chosen. So up here, when I was printing out all the digits, I should have had a default case. See out unexpected state. Right? That way when I'm testing the program, if that popped out, I know that my case statement, my switch statement wasn't good enough, that an unexpected value snuck in there, because otherwise nothing happens. You don't get any output at all, and you don't know, that there's something wrong. So it's a good idea to always put a default, even if all it does is print out an error message, because that error message is a lot better than a problem occurring silently because you forgot to leave out a case. For example, what if while I had been doing this, I forgot that I needed to put an E in there, right? I was missing that line. And then we passed in an E, and if this line wasn't here, it just wouldn't print anything. We wouldn't get any output whatsoever. We might not notice that we didn't get any output whatsoever, but if we had a default case, then we would. Don't I have that wrong? That should be F and E. My explanation. Who was puzzled by the fact that I had EFD? And who just didn't notice? All right. Anyways, the reason why it would need to be FED is because pressing a D should get you 1 3, pressing an E should get you 2 3s, and pressing an F should get you 3 3s, which by the miracle of fall through it would. So I'm just going to put that down as a comment here. I haven't actually made y'all type in any code today. Always put a default case, even if you don't think it's necessary. Just make it print out an error message, if nothing else. Unexpected state, something like that. Unexpected value for digit would be better, right? That tells us exactly what's wrong. Unexpected value for digit. And the break statement. We've seen break statements with loops, and now we've seen break statements inside of switches. Correct me if I'm wrong. We have seen break inside of loop. I see a couple people nodding. All right. So sometimes people think that you can use breaks in places that they can't. Break will exit loops. Break will exit switches. They will not exit if statements, if blocks. They will not exit a module level, a function level. Or any other time. The only things that they will break out of is while loops, do loops, and for loops, or switch statements. So what do I mean by that? I've seen people try to do this. If x is equal to 10, then do some stuff. Blah, 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 blah. And then if y is equal to 0, break. And they think that that'll leave the if block. And then there's some more lines of code after it, because that's what it does with a while. If that was a while, it would work just fine. A break statement would not be a syntax error. But it is a syntax error if it's an if, because the only things that break will exit out of are loops and the switch statements. So using a switch statement in a menu system. Switches and menus go together like bread and butter. You could ask the user for a choice, and then based on what they choose, you can do something as a result. So for example, in our sphere density program, right, switch based on the material. Case 1 was ice or something, right? See how ice set density equal to 0.8, whatever the density of it was, and then break. And you don't have to put everything on the same line, right? Normally you'll see it spaced out like this. And then we had another one. Case 2 was something else. I really don't remember the program that well. Aluminum, gold. And the density is equal to whatever the density of aluminum is. And then the third one was gold, and so on. Right? So we had some kind of menu. Right? We displayed the menu. And then we got the material with CIN. And then we displayed. Right? We did something based on it. We could have rewritten our code from our sphere program to use cases like that. As a matter of fact, if that's not a homework assignment, and we're going to make it one right now. And some of y'all have already done this. Some of y'all rewrote the sphere density. Okay, so homework A. Rewrite sphere density to use switch case rather than if else. That makes sense? We all think we can do that? I'm sure we can.
Next time we have class on Tuesday, right? Yeah, Tuesday. Would you be able to go over the original sphere density homework assignment?
Yeah, sure. Sure.
Because I was doing it and I got way off track. I started Googling and Stack Overflow and I ended up with a big old plate of spaghetti code.
All righty. Did you upload it for me to look at?
It wasn't going to go anywhere.
Go ahead and upload it just so that I can ogle it.
Because it was bad.
You deleted it? Okay,
yeah,
fine.
I started using all these lines and words that we haven't even gone over in class. I was like, oh, this is fun. And then
okay, remind me at the beginning of class, okay? Before anything else, remind me so that I can do that.
Thank you. I appreciate that.
As a matter of fact, we could probably do it now because we're at the end of the chapter. Am I right about that? More about blocks and scopes. What is block? What is a scope? Scope is the curly braces in which the variable is defined. So if I have this, int main, int x. X is valid all the way from here to the end of the function, which is marked by that curly brace. Now if I have another variable here, right, if I have this if statement, if x is equal to 3, right, and then I declare y, int y is equal to 4, and then I try to print out y down here. This is a syntax error in this language. Python would not call it a syntax error. Python is kind of weird. Python is not nearly as picky about scope as this language is. And when you took Python, we probably talked about scope and acted like it wasn't as picky, acted like it was picky, but it's really not. But anyways, this variable here is only valid inside these curly braces. So if we tried to print it out here, that would not work. Now if we put that print statement here, it worked just fine. If we wanted that variable to be accessible outside of this, we'd better define it up above that block. X is available anywhere in here, including all these nested braces. But Y is only available there. If we have another function up here, void t, and we define another variable, string name is equal to Bob, we cannot print out name down here. Name is out of scope because it's declared in the t function. Y is out of scope because it's declared in this block. This language supports global variables. A global variable is one that's declared outside of any function. So int fav color. Well, that's stupid. Int fav num is equal to 10. That's my favorite number. I can play with him. I can see out fav num here. That is not a syntax error because it is declared as a global. And I can print it out here as well. See out arrow fav underscore num arrow endl. That's fine. It's global. And these functions can change its value, no problem. If we call t and it sets favnum equal to 1,000,000, well, if we ran this program as is, it would not print out 1,000,000. I don't know if that's 1,000,000 or not. I don't know if I have the right numbers of zeros. Okay. Like by the time it got here, assuming that these two statements did not crash or, cause the compilation to stop, which they would, it would print out what? It would print out that the fave number was 10. Why? Because nothing ever changed it, right? Starting from here, that didn't change favnum, that didn't change it, that didn't change it, that didn't change it, that didn't, so it's going to print out 10. The only thing that's going to change it is if we call this function up here. So then if I put a call to t, and then I print it out, then it's going to print out 1,000,000. Now, global variables seem like they are really useful things. And maybe they are, but you should try to avoid them. And the reason why is because they make the code harder to read. You're looking at a CPP file and it's referring to a variable and you just flat out cannot find that variable anywhere in your code. And it's because it was declared in another module, in another CPP file. And you don't really know what that CPP file is doing with it. Or somebody writes some code that changes your global variable and you don't know that it's changed because every function has access to it. So kind of avoid global variables if you can get away with it. I would never say that there's absolutely no need for them. But see if you can define it as a # define instead. And stick it in a header file. And all the projects, all the C files in your project can then use that header file. And that'd be a good thing for us to do. A better thing for us to do, though, would be to talk about the sphere density program. So I need to make a note to myself to talk about global variables and # includes in header files. It's about time to do that. So header files, global variables, and # define. Talk about on Tuesday. Okay, so the sphere program. Let me go back and look at the homework assignment the way it was written. So this is a menu-based program. So it's going to present a menu that says choose a material. So it's going to print this message out. And then it's going to use CIN to read it in. And then it's going to print this message out. And it's going to use CIN to read it in. And then it's going to do some calculations. So inside main, we're going to need a couple of variables. We're going to need a variable to hold their choice of material and their choice of size. So why not ints? chmat for choice of material. And int ch size for choice of size. So let's display that message. Choose the material. And then let's see out the first one. 1 equals ice. See out 2 is equal to whatever. That's about enough. I'm not going to do the whole thing. And then we're going to let them type that in. So CN into chmat, the choice of material variable. Or I could have just called it material. That would have been a little bit more explanatory. So I'm going to do that. Based on the material, I can calculate the density. So if parentheses material is equal to 1, I would set the density equal to something. But I don't have a density variable. That's a problem. Looking at our chart on the next page, the density of ice is 55. So if material is equal to 1, then the density is equal to 55. Else if the material is equal to 2 for aluminum, then the density is 168. Else we have an error case, right? So our error case had better warn them that they picked a bad material. Cout unknown material. Defaulting density to 1. There could be other ways to handle it. You could force them to loop until they choose a good one. So there we go. We've gotten our first piece of input. My syntax error would be that I have not declared a variable to hold the density. So I think I would do that. Double density is equal to whatever, you know. Or just leave it as 1, and so we would accept the default value later. Same thing for the sizes. We need to display a list of sizes. Cout arrow arrow size question mark. How did I want my output to look? 1 and 2, 3. Okay, cool. 1 equals marble. 2 equals beach ball. Whatever, right? A lot more choices than that, but that'll give you the point. And now we need a variable to hold that. But I declared one up here. I called it something stupid, ch size. I'm just going to change that to size because it makes more sense. Scroll down here and cin into the size variable. And based on that, I can calculate the radius, which we're definitely going to need later. Double radius. And then if they choose a size of 1, then we need to do something. So if the size was equal to 1, it's a marble. Which has a diameter of 0.05 feet. So radius is equal to 0.05 divided by 2, really, because if that was the diameter, okay, fine. Double diameter is equal to 0. And then the diameter is going to be equal to 0.05. And then we're going to divide that by 2 to get the radius later. Else if size is equal to 2, then the diameter is equal to the beach ball. .67 feet. Else we have a problem. We're going to see out an error message. Cout unknown size. Default of 0 will be used. So obviously anything that happens after this is going to be wrong because we're using 0. Maybe we should have defaulted it to 1 instead. Default of 1 will be used. Something like that. Now we have all the information we need to figure out the radius of it, the volume of it, and then the mass of it based on our 3 equations. So we need the radius first. How do we calculate the radius based on the diameter?
I don't think the radius equation is in the. Radius is just half the diameter.
Right, it's half the diameter. And so if you didn't know that, I apologize. I should probably add that to the assignment. But the radius is half the diameter. And so then the volume, I do believe that equation is in there. 4/3 pi r cubed, something like that. Yeah. So 4.0 divided by 3.0. The reason I'm adding the point O's is to make sure that absolutely no rounding down happens. Times pi, or 3.14159, or however you want to handle it. You can import CMath and figure it out. It always seems a little bit quirky to try to get a hold of that. Times POW of r to the radius to the power of 3. And based on those 2 things, we have the equation for mass, which is volume times density. So double mass is equal to volume times the density, which we calculated up here in our if statements. Pardon me? Pi to the... My equation's wrong then. Because it really is to the cube, because r squared would just give you square feet. So I done did it wrong.
Yeah, I think that's where I messed up too. I couldn't figure out why it was wrong or where it was wrong, so I started Googling the Stack Overflow, and that's when this became
My mistake. Guys, if you've already uploaded it, I'm not going to count you wrong. If you haven't done it yet, please use r cubed rather than r squared. Because to get cubic feet out of it, we do need to multiply the radius by itself 3 times. I'll re-upload the assignment. And now we're good. We could just write out all the information at that point, right? See how volume is. Cubic feet. And then the mass is. And I'm not putting spaces in the correct place. Pounds. Like that. So let me guess, you actually had like 90% of it right, and just because I left the radius off. Or
It wasn't even that. I know my math was off because when I put it into this calculator that I made here, and I put it into Google, and the math was off. So I was like, why is it wrong? Yeah. So then I just went down this rabbit hole trying to fix it, basically.
well, it's entirely possible that my values are wrong. Maybe I got the wrong densities. I did have a chart. I pulled that chart in. I hope it's correct. But normally this stuff is measured in grams per cubic centimeter and stuff like that. And instead I did it in English units, which made me less sure that I was getting the correct values. But we don't, most of us, all of us Americans who don't know the metric system like the back of our hands, like using pounds and feet. So that's why I did it that way.
Even though the metric system's easier than pounds and feet.
It's way easier. Yeah. Yep. All righty. So we're good now? That makes sense? And for those of y'all who are going to do the next assignment, which is going to be all of y'all, hopefully it's real easy to see how you're going to change this to use switching case, right? You're just going to switch material. Case 1, density is equal to that, break. Case 2, density is equal to that, break. Default, print out unknown material defaulting to 1.
It's good for me.
All right.
Don't forget the Dropbox for the notepad that you wanted us to upload.
Yeah, good point. All righty. So there's going to be a Dropbox for those of y'all who are watching at home that says, Prof, change my grade. And you can upload notes about test score points you want, or if you've seen a grade mistake. All righty.